Welcome back one more time. This time we are going to discuss mechanical energy, and this will be part 2, because we've already discussed what mechanical energy is, part 2, but I will just kind of give you a very quick review. Remember that mechanical energy, I'll just write it kind of in short forms, mechanical energy is equal to the sum of, or adding together of, the kinetic energy that something has, EK, kinetic energy, and the gravitational potential energy, which I call EG, to remind us that these are all forms of energy. All right? So we sometimes can write this as E mechanical equals EK plus EG. All right? And the other important thing that we have to remember is that the mechanical energy, the total E mechanical, the total mechanical energy at any one position is equal to the total mechanical energy at any other position. In other words, mechanical energy, the total mechanical energy, is always the same. I'll just squeeze in position here. And this is what we're going to do today. We're going to use this second point to actually take the picture of the roller coaster. You'll recall that we were talking about a roller coaster, and we will use that, or use this to actually figure out some of the numbers that would go with that roller coaster. So those are the two things that we're discussing. Let me draw a picture of our roller coaster now. We're going to start with the track that goes up like this. It's going to come down like this, up a little bit here, and then down a little bit more, and then level off here at the end on the ground. So that's kind of where the ground is, right there. There's the ground. Okay. And to start off, I'll give you some information about it. Here, let's put a little red roller coaster car ready to go. At the beginning, what we'll call position 1 here, this would be the height of the roller coaster. And we're going to say the height is 50 meters. That's how high it is, very high. So it's going to be a fun ride. Now, what we want to do is we want to try to figure out something about the energy and the movement or motion of this roller coaster car at different places. So I'm going to identify some places. Here's position 1 right here. So I'll put these in purple. Position 1 will be at the start. Position 2 will be right here when the roller coaster car gets to the bottom of the first hill. Position 3 will be when the roller coaster car is sort of right here at the top of the second hill, or I guess you could say it's the first hill after the initial drop. And position 4 will be right down here after it's almost at the end, as it rolls off the last hill. Okay? And what we want to do is we want to use we want to figure out some of the things that are happening. Now I'm going to tell you a few more things. I'm going to tell you that at position 2, the height of the roller coaster is 30 meters. So it's a little bit lower. See, we dropped down from 50 down to 30. All right. And let's see. I'm also going to tell you about position number 3. Maybe I'll tell you the speed for position number 3. But I have to make sure we use the right number for that, so I'll have to just figure that out for a second. Okay, so if I figure out that the speed at this point, I'll put it right here. The V, the speed, is going to be 14 meters per second at position number 3. Okay, The only other thing I have to tell you is that this little car, I'll put it right down here, has a mass. Actually, you know what? I don't even have to tell you that. We'll keep it a secret, the mass of the car, and I'll show you why. All right, so let's begin by asking ourselves, so at position number 2, the first question we want to ask is at 2, position number 2. We want to know how fast is the roller coaster going, the roller coaster car. How fast is it going? All right, so the way we do it is by using this mathematical sentence up here, that the total mechanical energy at any one position is equal to the total mechanical energy at any other position. And remember that mechanical energy is EK plus EG. All right, let's put it all together. This is kind of like the hardest part of the problem. So if we put it all together, we can write that the mechanical energy at position number 1 has to equal the mechanical energy at position number 2. Because energy can't disappear. That means that if I calculate the kinetic energy at position number 1, see how we use the little ones to keep track, and I add it to the gravitational energy of position number 1, that is how you get the mechanical energy. So the mechanical energy is equal to adding up of those two things, right? We said that already. Okay, so now that equals, at position number 2, the mechanical energy is still the sum of those two things, but they'll be different. So I'll put a 2 to show that they're different, you see. They are not the same because the height has changed and the speed has changed. Okay, now you also remember that in the last video we said that kinetic energy is calculated by 1/2 mv squared, and gravitational energy equals mgh. We learned that in our last video, so we're going to combine that as well. So now if I look at EK1, well, that's the same as 1/2 mv squared. And the v I have to use is the speed it's going at position 1, because that's all for position 1. And over here, mg, and I need the height of position 1. So you see why I put the 1s. They just help me keep track of which numbers go where. Because we have many different heights in the roller coaster, and we have many different speeds. Now, over here, kinetic energy is 1/2 mv squared, but guess what? The speed here will be different, so I'll put v2 to remind me it's a different speed. And then over here, I'll put mgh2. So you can see that it looks complicated, but it's not really. We're just turning one thing into the other, right? We're saying that the mechanical energy is equal to that, so that can take its place. And that is equal to that, so that can take its place. And so now what we're going to do is we're going to notice something about this equation. If you remember your rules of math, you can do anything you want to one side of an equation as long as you do it to the other. And if every term, remember in math, we call these things, these big chunks of stuff that are separated by pluses and minuses, we call them terms. So we have 4 terms. But if every term has the same numbers sort of in it, you can divide those numbers on both sides and they'll cancel. Remember that? So what I'm going to do is I'm going to divide all of my terms by mass, by m, which I'm allowed to do as long as I treat everybody fair. If I divide this by m, well, m divided by m, we say it cancels because it turns into a 1. So this becomes just 1/2 of 1 times v1 squared, and we don't need the 1 anymore. And if I divide this by m, it just becomes gh1. And if I divide this by m, it's 1/2 of v2 squared. And if I divide the last one by m, it's, just g times h2. So the m's have disappeared. That's why I didn't have to tell you what the mass of the roller coaster car was. We don't even need it. It's gone from our work. And that makes our life simpler. All right. Let's try to figure out what we have in our scenario. Okay. Let's look at position 1. We know we have a height of 50 meters, right? Our height here is 50 meters, so that means that that can be h1, the height of position 1. Now, what do you think the speed would be for a roller coaster that hasn't even started to roll yet? Well, the v here is actually going to be a 0, isn't it? Because it hasn't really started, it's rolling. It's just reached the top, and it's just about to start, so it has a speed of 0. So now I know two things about position 1. So let me go back to my equation and fill those in. The speed of equation 1 is a 0. So that means it's 1/2 of 0 squared, and the height at position 1 is 50 meters. So that becomes g times 50. All right. Let's see if there's anything for position 2 that we can fill in. Position 2, we know the height is 30 meters. So I can fill that in. Now that's all we know. We don't know anything about the speed, but remember, that's what the question was asking. The question is asking for v. So we have h. So we're going to move down here. h2, we know is 30. So we don't know what v is, so we're just going to leave it alone. If we don't know what it is, we leave it in. But we know that the h is 30 meters. So we put that in. Now we do know one more thing, and I guess I could have done this at the same time, but I'm going to do it in 2 steps just so nobody gets too confused. The little g, remember, don't forget, g is equal to 9.8, right? We've already talked about that. So that means I can also put that in. So I'm going to do a couple of other things. What's 0 squared? 0. Half of 0 is 0. So the kinetic energy is gone. And that makes sense, because if the car is not moving, it cannot have any kinetic energy. So it's kind of like the math already knows that. And this would be 9.8 for the g times 50, which was the height in position 1. Over here, I still can't do anything to this because I don't know anything about it, so I just have to leave it alone. But over here, this would be 9.8 times 30. Well, now the math is kind of telling me what to do, isn't it? It says, you see those brackets you have there? Multiply them. So I'm going to multiply 9.8 times 50, and that'll come out to 490 equals 1/2 v2 squared, and then this would be 294. 3 times 8 is 24, 3 is 27, 29, 294. Okay, well, things have gotten a lot simpler now, haven't they? Now the next rule of equations that we like to use, if you think back to grade 9 and 10, you learned how to solve this. You learned that we can subtract 294 from both sides. So when you do that, it's like the 294 gets moved over, right? So if we subtract it from here, now if I subtract it from the other side, I could write plus 294 minus 294, but of course that's just going to be 0, so it's kind of like gone. So the next thing we can do is move that to the other side. Okay, good. And now we can subtract. That's easy to do. 490, and if we subtract 294, we're going to get 196. So now we've made this even simpler. The last thing we want to do is we're trying to get the v by himself. We want it to say v equals, right? That's what we're after. So because of that half, if 196 is half of the v2 squared, then double that should be the v2 squared. So the way we get rid of the half is to multiply both sides by 2. So if we multiply both sides by 2, we get 392, and then half of this times 2 turns into v2 squared. Okay, and now we take the square root of both sides, and if you take the square root of both sides, you'll get 19.8-ish equals v2. So that means that the speed is 19.8 meters per second. V is 19.8 at position 2. That tells us how fast the cart is actually rolling. If we go back to our picture, it makes sense because it starts at 0 and it rolls down the hill. It's going to get going very fast when it gets to position 2. Okay. Now we're going to do the exact same thing for the next part of our question. All right. So let's go back. I didn't write it down, but let's call this question that I wrote here part A, question A. The next one will be question B. And question B is going to be, how high is position 3? We would like to know how high this is, because I didn't tell you that. So that's going to be the height of position 3. But the speed at position 3 is 14 meters per second. So we're going to go back and do all this again. Okay? Now, you know what? To save us a little bit of space, because I have to keep going back to the picture, I am going to just erase this. You can look back in the video if you want to look at it again, so it's still there, but for me, rather than going all the way down the page, let's just erase this and start over so we can stay close to it. I'll leave those things there because they're useful. We can use them. Guess what? We're going to start this exactly the same way. We're going to say that the total mechanical energy at any one position, position 1, is going to be equal to the mechanical energy at any other position. So I'm going to use position 3. Now, the first one doesn't have to be position 1. You could use position 2 and position 3, because we already know about position 2. The reason I'm choosing 1, though, is because remember what happened at position 1? The kinetic energy was 0 because the speed was 0. And that just made it simpler. I didn't have to do any calculating for that. So I'm going to use position 1 as my first spot, and I'm going to use position 3 as my second spot. So when we say that the mechanical energy at one position is equal to the mechanical energy at another position, all we really mean is any two positions. It doesn't have to be position number 1 or position number 2 or 3. Any two positions will have the same. Okay? So I'm going to use the numbers 1 and 3 so on our picture we can be sure which spots we're talking about. And the next part is the same. The kinetic energy at position 1 plus the gravitational potential at position 1 will tell me what the mechanical energy is. And the kinetic energy at position 3 and the EG at position 3 is the mechanical energy of position 3. So far we don't even have to know anything. We just know what those are equal. And this is 1/2 mv squared. We learned that before. We use the speed at position 1, and this is mgh, position 1, and this is 1/2 mv3, the speed of number 3 squared, and this would be the mgh3. We already have a lot of numbers, right? If we go back to the picture, we can see that we have 0 for the speed at position 1 right there, and 50. So we can use those. And then we have 14, and then we don't know this height at position 3, but that's what we're after. Okay. Now remember what I said about the m's. The m's can all cancel out of the equation as long as they occur in every single term, which they do. There's an m everywhere. So we can divide everything by m, and we can change this to this equation, which is a little bit easier. And then we can put in all the numbers that we know about. We know that the speed at position 1 is 0. We know that g is 9.8, and we know that height number 1 was 50 meters. Oops, I just noticed that I put a plus here instead of an equals. Better make sure we fix that. Next here, we have what? 1/2. This time we do know the speed at position 3. I told you it was 14. So we'll put that in there, 14. squared. And then we know that G is 9.8 again, and this time we're trying to figure out height number 3. We don't know what the height is. So now what we do is we crunch all the numbers up. This is 0, this is 4, 90. Now this time we have to do a little bit of different math. We have to square the 14 first, and if you square 14, you get about 196, and then divide it by 2. So that comes out to 98. And then we have plus 9.8 multiplied by H3. Well, just like before, we can subtract 98 from both sides, so it kind of feels like it moves over to that side of the equation, right? 490 minus 98. And of course, when I subtract it from the right-hand side, it just disappears. I've taken it away. And if you do 490 and you subtract 98, you should get about, what, 392, I believe that would be. Oops, I went a little too far there. Hang on. I got to keep erasing all this other stuff from before. We don't want that to confuse us. Okay, so 490, take away 98 is 392, equals 9.8. Now we're going to divide both sides of the equation by 9.8. And if you take 392 and you divide by 9.8, you get 40 equals H3, which means that the height at position 3 is 40 meters. It's 40 meters high. And if we go back to our picture, we can see that that makes sense. That's why I kind of had to stop for a second and figure out a good speed. I couldn't just make this 14 up. I had to know exactly what it should be. So you can see how if this is 30 meters and up here is 50, that looks like it's kind of in the middle. It could be close to 40, so it makes sense. Alrighty. The very last thing we're going to do is we're going to do part C. We're going to look at position 4. Now, I'm not telling you anything else about position 4, but what part C is going to be is to look here at position 4, and we're going to try to figure out how fast it's going. What will the V be at position 4? So let's, again, I'm going to erase what I had before, okay? And I'll just do it underneath there. And if you want to go back and look at that, just rewind the video and go back and have a look. We'll just erase all of it so that we don't get confused. There we go. All right. The beautiful thing is, for question C, okay, so question C, I guess I better write it. What is the speed at position number 4? Maybe you haven't noticed, or maybe you have, we've been using the same procedure for all of these questions. And that's kind of the beautiful thing. All you need to know is how to do one thing, and it will figure out anything about this that you needed to figure out. The mechanical energy at any one position, and we'll use position 1 again because we said that was a nice easy one, equals the mechanical energy at any other position, so that must be position 4. I could use 2 and 4, I could use 3 and 4, but I'm choosing 1 because I know it's an easy one. Remember that. So the kinetic energy at position 1 plus the gravity energy at position 1 equals the kinetic energy at position 2 plus the gravity energy at, position 4, not position 2, position 4, my mistake. Okay, 4 and 4. And we do the same thing again. This means that 1/2 mv1 squared and mgh1 equals 1/2 mv4 squared plus mgh4. And of course, as before, all the m's disappear. They cancel out of the equation by dividing every term by m. So we're down to this. So you can see how this part is really becoming just kind of like boring. It's the same every time. You just have to kind of remember it. If you're really sharp, you might just remember this part, and maybe you just start here. You don't have to do all this writing each time. It's up to you. Okay, now we're ready to see what kind of numbers we have. Well, we're still using the same numbers from position 1. Those didn't change. There was 0 speed and 9.8, and it was 50 meters high. Position 4 is different. We're trying to find the speed, so we don't know that. Okay. And what's interesting about position 4 is, look at the picture. At position 1, we had no speed, but we had lots of height. At position 4, we have speed, but we have no height. We're on the ground. This is as low as you can go. So that means that the height for 4 is going to be nothing. So we can go now and we can find our right here's where we're at. The height of position 4 is nothing. So the G is 9.8 and this is 0. So this will be a nice easy one because look, this side, the 0 times a half, that's all gone. This is 490. And over here, it's just 1/2 V4 squared. And 0 times 9.8 is 0, so that's gone. And so this makes it a little bit easier. Get rid of our stuff down here. So now what do we do here? Do you remember? We want to get rid of the half. So we're going to multiply both sides by 2. Right? Multiply both sides by 2. So this will become 980, and this will just become V4 squared. And then, if I take 980 and I figure out the square root of it, which that works out to about 31.3-ish, that will become the speed. So you might want to write down here what you did. I didn't show it mathematically, but what we did is we took the square root of both of these sides, right? The square root. And that would be V4. So that means that at position 4, speed is 31, very fast, meters per second. 31 meters per second, remember, is like 100 kilometers an hour, or close to it. Actually, a little bit more. The speed is 31.3 meters per second. That's fast. And that makes sense, because when the roller coaster has gotten to the bottom, all of the height is gone, which means all of the gravitational energy has been turned into speed. So that's when it's going the fastest. That's when it's going the fastest. Okay? All right. So what I'm going to do is I'm going to give you an example of this to try on your own, and then that will form your assignment for this section. And this is really a lot of math, and this is a little bit tricky, but if you follow the videos and you go through step by step, you should be okay. All right? So practice it until you can kind of get the hang of it. And so if you look back on your LMS page, you will see there's an assignment that goes with this video, and that's what you want to hand in the Dropbox. All right? And that's the end of our show for today.